上个世纪60年代，有位物理学家将他的射电望远镜对准了太空，他要观测的星体位于猎户座。当他将望远镜对准目标星系时，他发现自动记录仪在不停地颤抖。虽然这种颤抖是有一定规律可循的，但是这位物理学家并没有注意到这种情况，他更愿意相信这是设备出了问题。于是他对着自己的仪器轻轻地踹了一脚，记录仪上的颤抖消失了。物理学家满意地继续开始他手上的工作，更满意自己临门一脚的机智，修理了不听话的机器。只是他并不知道，诺贝尔奖悄悄地和他擦肩而过，丰厚的奖金快乐地和他说了 goodbye。 1967年，英国剑桥大学造了一架新型的射电望远镜，它的作用是观测射电电伏受行星际物质的影响。什么是射电望远镜？射电望远镜是一种用来接收和分析天体发出的无线电波的仪器，它可以让我们探索宇宙中不可见的奥秘。当电磁波从宇宙射向地球时，大气层会将大部分电磁波吸收掉，只留下可见光和部分电磁波，留下来的这部分电磁波就被称为射电波。射电望远镜与我们熟知的光学望远镜截然不同，射电望远镜没有光学镜头，无法让人通过肉眼直接观测经过透镜放大的天体。天线就好比射电望远镜的眼睛，用来收集宇宙中微弱的无线电信号，再经过接收系统将信号放大，然后经过降噪处理分离出有用的信号，通过分析这些信号确认天体的特征。射电望远镜的发现可以追溯到1931年，当时贝尔实验室的卡尔央斯基在研究无线电干扰的时候，意外地捕捉到了来自银河系中心的射电信号。他用一台类似旋转木马的天线阵列进行了信号收集，这是世界上第一台射电望远镜。剑桥大学的这台射电望远镜性能相较于之前的望远镜提升了不少。1967年7月，这台仪器正式投入使用。1967年10月，剑桥大学卡文迪许实验室的安东尼·休伊迪什教授的研究生24岁的乔斯林·贝尔伯奈尔在检测射电望远镜收到的信号时，无意中发现了一些有规律的脉冲信号。细心的贝尔发现，这些脉冲的时间间距精确的相等，它们的周期十分稳定，为 1.337 秒。贝尔小姐立刻把这个消息报告给她的导师休伊什。休伊什认为这是设备受到了地球上某种电波的影响，不用理会。但是这样的解释无法说服细心的贝尔。在后来的几天，也是同一时间，也是同一个天区，那个神秘的脉冲信号反复出现，这足以证明这个奇怪的信号不是来自于地球，它来自于地外。起初他以为这是外星人小绿人发来的信号，这让他激动不已，在自己有生之年就找到了地外文明的线索。这些信号很有可能蕴藏着人类接触外星文明的密码，想想都让人激动到爆炸。但在接下来不到半年的时间里，又陆陆续续发现了数个这样的脉冲信号，这就有些奇怪了。难道外星人组团来地球扫货了？难道牛排、炸鸡、油条、豆浆、葱油饼这么吸引人吗？后来人们经过严谨的分析和确认，这是一类新的天体，并把它命名为脉冲星。1967年，阿拉斯加弹道导弹预警中心的雷达控制人员也观察到了一些脉冲信号源，并确认它们来自地外天体。这一发现早于剑桥大学的研究人员，但由于军事保密要求，直到21世纪解密之时，这一发现才被世人所知。脉冲星与类星体、宇宙微波背景辐射、星际有机分子一起并称为20世纪60年代天文学四大发现。剑桥大学的安东尼·休伊什教授，也就是乔斯林·贝尔的老师，因脉冲星的发现和同事马丁·奈尔荣获了1974年的诺贝尔物理学奖。可是贝尔本人却成了默默无闻的垫脚石。事实上，贝尔不光因为自己的细心捕捉到了这些丝毫之间的差异，更是对数据分析进行了大量的验证和理论研究。对于科研人员来说，也许他们更多看重的是研究本身，奖项只是肯定他们工作和兴趣的一种方法。诺贝尔奖可以记录对科学有卓越贡献的人，如果获得诺贝尔奖是评判科学家成就的重要标准，但对科学有卓越贡献的人不一定会被诺贝尔奖收录。对这些不被收录的人，到底是公平还是不公平？谁来判断呢？
Since the dawn of humankind, we have shared a deep communion less than a century ago with the stars. Before the 1930s, optical telescopes were the only kind. The universe around us inspires many of our most powerful beliefs with these early about tools. Who we are and where we come from. In 1932, Carl Jansky made the startling discovery that objects in space, on our journey of cosmic discovery, there have always since then places pioneers with ever more complex instruments have pushed the science forward, places that help us make sense universe of all the wonders we see when we look to the skies above. Since its completion in 1980, the VLA has been making astounding discoveries, from water ice on Mercury to the remarkable jets of elliptical galaxies and the physics behind gamma ray bursts, the most powerful explosions in the known universe. 50 miles east of the array lies the Rio Grande Valley about our universe and the old Spanish missionary town telescope of Socorro, which capture visible light just as our eyes. The telescope's scientific center is located here. Far from the cold and wind like our high desert, these telescopes can only see the stars. Astronomers uncover the latest chapters in the story of the cosmos. Dawn brings an end to observations and to this
as an
astronomer's
I spend
workday.
A lot of my time sitting at my desk.
There are other telescopes built on a more massive
observations from telescopes
that work
like
around
the
the clock,
most of the
gathering
time
invisible
spent
light
reducing
from
that
space.
data, analyzing that data, and trying to figure out
The
what's
Carl
going
G.
on.
Jansky Very Large Array. Out of the vast reaches of space, this vast collection of dishes is among the most accomplished telescopes in history.
Pennies 210 is visible in the south, and it's in the constellation Pyxis, and it's about 30 million light years
These
away.
radio telescopes,
It's a very small little
like
galaxy,
giant
but
flowers
it's a
from the New
hot
Mexico
spot for
desert,
star formation.
are monuments to human
There are
ingenuity.
these young, massive star clusters forming today, and these are similar to the types of clusters that were formed back
We are
in the
going
early
to get there
universe.
first, and you have the knowledge.
Pennies 210 is 10 times farther away than the most distant object we can see with the naked eye.
The heavens.
But in astronomical terms, this dwarf galaxy is our neighbor. Its closely held secrets have been shrouded by dust and gas, but radio light can escape and can be captured by the VLA.
I think it's because we're looking for the meaning.
On
What
Earth,
is the meaning?
This extremely
mindless
weak
jobs.
light
We
must
take
be
granted
distinguished from
vacations,
thousands of other
just
man-made
finance
sources
trips
of
to
radio
the mall,
interference.
buy more things that we think are going to fill these
In a
holes in our
custom-built
lives.
test chamber, VLA engineers measure the impact of radio interference given off by even the most everyday devices. But beyond its fame as a scientific landmark and backdrop for talented actors,
Oh, yes.
the
So you
VLA
can see we're
is the
getting some
foremost
really strong
astronomical
RFI here
instrument
in
of
the
its kind.
2.4 to 2.5 gigahertz range.
Even with no hundreds of astronomers, the radio emission cutting-edge science next to an antenna is some
My name is
20
Amy
trillion
Rines. I'm
times
36 years
stronger
old, and I'm
than
an
the most
astronomer.
powerful radio source in deep space.
Every time I come out here, I'm surprised at the effect that it has on me.
Miles away from the safety of the lab,
You're sort of
another
out in the
crew
middle
is
of
about to
nowhere,
undertake a more
yet
daunting
there's this
task.
contrast with all the technology, with these amazing dishes and all the work that goes into making the science happen.
Are you Amy? I'm Gene.
30 feet above
ready to
each
go up on the
antenna's
umbrella?
dish
I'm
is a
fascinated
structure
by the
called
early
the
stages
apex.
of galaxy evolution.
Every few
back when
months,
the universe was in its
personnel climb the
infancy.
thin beams
And I
to
just
reach the
want to
apex
know,
for critical
where
installation
does it all
and
come from?
maintenance
How does it
of
all
the
work?
VLA's
What's our
P-band
place?
receivers.
It's hard to study
With
these
gusting winds
early
and
galaxies
difficult footing,
because they're so far
harnesses
away.
are a must.
By studying dwarf galaxies today, we hope to try
Only
to
the
gain
smallest
insight
crew
into
members
the
can squeeze
formation
into
of the
the
first
apex
massive black
itself.
holes. And this is the kind of work that would not have been done previously and cannot be done with any other instrument
As
on
the
Earth.
crew works, the rest of the array is still making observations.
Go ahead. Yeah, can you give us color code for the RCP, LCP?
These low-band receivers are especially important for detecting invisible hydrogen gas in the early universe, the main ingredient of future stars and galaxies. Regular upgrades like this are crucial to keep the telescope functioning at the level required by astronomers. But the entire array has also recently undergone a complete reinvention on a massive scale. After decades of stunning science, The 1980 vintage VLA was in danger of becoming obsolete. Without the resources to construct a new instrument from scratch, NRAO devised a strategy to rebuild the telescope from the inside out.
We were able to conceive of a plan that would keep all the antennas the same, keep the rail tracks, keep the infrastructure that supports this instrument, but completely rebuild the electronics.
Over the course of a decade, crews have worked to replace nearly all of the technology inside the telescope, creating a new instrument within its original skeleton. At the center of the VLA expansion project is the development of a new supercomputer called the Correlator. In a meticulously controlled clean room environment, this incredible machine, contributed by Canada, turns 27 radio dishes into one gigantic telescope. Huge data streams from each antenna are fed to the telescope's control building, where the correlator increases the telescope's capabilities more than 2,000-fold. After a 10-year effort, the reinvention of the VLA is finally complete. To integrate the newly upgraded antenna with the rest of the array, the telescope's maintenance crew must perform another vital task high on the desert plains in an intricate dance between man and machine. Not only do the VLA's antennas move to track objects in the sky, they also move throughout the array itself, on the backs of custom-built antenna transporters. Engineers maneuver these 90-ton flatbed locomotives underneath the antenna's triangular base. 230 tons of steel and sensitive electronics is hoisted into the air, and the 94-foot-tall structure is slowly unveiled. The antenna's sheer size makes transporting it a potential hazard. The crew cannot move antennas in winds of more than 20 miles per hour. And maximum speed is just under 5 miles an hour. The array is crisscrossed by more than 40 miles of railway lines. The antennas are moved along tracks that lead 13 miles out from the center of the array to 72 separate antenna stations. These stations are connected to the main track by perpendicular spurs. When the transporter reaches the desired station, engineers use hydraulic jacks to pick up its wheel trucks independently and rotate them 90 degrees to make the turn. They carefully set the structure down, and the upgraded antenna makes its new home in the vast array. About every 4 months, the antennas are moved into one of 4 different configurations, A through D. Each configuration changes the depth and detail the telescope sees. Combining data from all 4 configurations delivers the best image quality. When the antennas are packed together in the D configuration, the telescope can see faintly glowing clouds of gas. When they are at their farthest distance from each other in the A configuration, they reveal the finest details of the radio universe. Now, with antennas fully spread out, the VLA is finally ready to observe the dwarf galaxy Henneis 210. The world's most storied radio telescope prepares to once again open its eyes on the universe.
Copy that. We're getting ready to run the C-band observation.
The antennas turn toward the southern sky. In the darkness above, the light that left Henneis 210 some 30 million years ago finally approaches our Earth. It has traveled more than 150 quintillion miles and persevered through gas and dust to share its secret. The VLA's dishes lock onto the faint beam of light coming from Henneis 210. The radio emissions flood the telescope. And for a few short hours, two distant realms share a fleeting connection. An entirely new catalog of human knowledge is captured and recorded. And this 21st century astronomical instrument plays its part in a human journey that began many ages ago. After 6 hours, the telescope moves on to a different target. But the secrets from the distant galaxy have been saved on a microscopic scale. Like messages in an ancient language, they must be deciphered.
Our team just finished reducing all of our new data, and we have some spectacular images now. And we can do a very detailed comparison between the optical data from the Hubble Space Telescope, the infrared data from the Hubble Space Telescope, and now the radio data from the VLA.
The VLA observations reveal a tantalizing discovery.
We found this source of radio emission that looked very much like it might be a supermassive black hole in this tiny little galaxy.
Deep in this dwarf galaxy, less than 30 times smaller than our Milky Way, a hulking giant is feeding on the surrounding gas.
This has implications for our understanding of the evolution of galaxies and their black holes, and even the formation of the first black holes back in the early universe. The VLA data here is really crucial for this discovery, and it would not have happened without it.
This shows a globe of that area, showing the activity, everything we're going to talk about.
Discoveries like those unveiled by Henneis 210 are being made with increasing frequency as astronomers make use of ever more powerful instruments.
On the upper right, we have Centaurus A.
With its expanded capabilities, the VLA promises to serve humanity into the next generation and beyond.
Let's count how many there are. 1, 2, 3, 4, 5, 6. Yes, ma'am.
There are 28 of the VLAs.
Very good. There are 28 dishes or antennas.
And on this windswept plain in New Mexico, the seed of tomorrow's revelations is already being planted. As a new age looks up on the sky and wonders.
I believe all mankind has that innate desire to know the origins of his being.
Astronomers from all over the world want to use the VLA to uncover the secrets of the universe.
We are adding more and more to our understanding of the universe. You don't have to be a scientist to be thrilled by that.
We've always had the night sky to look at, to ask questions about, and to wonder why it looks the way it does. Why is it that the Earth happens to be the place where humanity has grown up? What is special about that? And the only way you can understand that is by looking at other stars, other solar systems.
The iron that's in your blood, the calcium that's in your teeth, all those things were made inside those stars.
The good thing about astronomy is that it's not just something to make profit, but it's something that actually might lift the spirits of everyone.
You know, for me, astronomy has to be a part of any civilized society, like music or art.
But I think it's very important to be always asking questions. So I hope that coming to the VLA inspires people to ask themselves questions.